OpenAI had an announcement about O3. It's a very interesting twist to the whole debate about is AI going to take over our jobs. If you go to the OpenAI website, you won't see anything about O3, which is super strange. O3 is the new model that has been announced by OpenAI. Okay, it's a new AI model that has been announced. It's not released, it has been announced. And it is supposed to be one of the most capable models that is available. OpenAI O3 breakthrough high score on ARC AGI pub. There are a bunch of things here that you need to understand before we get into this announcement. OpenAI O3 is the new model that's been announced. High score on ARC AGI pub. What is ARC AGI pub? So there's been so many discussions about AGI. You folks know what AGI is? Artificial General Intelligence. Basically, the idea is we have artificial intelligence in different capacities, right? There are some complex artificial intelligence, there are some simple stuff, different abilities for this artificial intelligence. The goal is to somehow get to a point where the artificial intelligence is so complex that it can do anything that you want it to do, and it basically overtakes a human. Okay, think about human intelligence. A human intelligence is not specific to a certain niche, right? You can teach a human to do anything, right? A human can be an engineer, he or she can be an artist. There are a whole range of things that a human being is capable of. But if you take an AI, it's capable of a very narrow portion of that range, right? It's not general intelligence. It's very specific to certain narrow things. You have an image model which can generate images. We have a language model which can generate language, which is great. But now what if you want a model which can perform like a human, a model, or basically a set of models, right? When you have an AI that has this general intelligence which can do all kinds of stuff just like a human can, or perhaps exceeds a human capability, that's when you say that you have reached artificial general intelligence, or AGI. Okay, AGI is kind of like the holy grail for, like, or the north star for people working on AI. You're working on AI, you want to get to a place where you get to AGI, where you have an AI which can do anything, right? It speaks about both the capabilities, the range of capabilities of AI, and also the extent of the capability. Like in any particular capability, how smart the AI is, right? It has to be wide, it has to be a generalist, and it also has to be smart. Okay. So people are working on, right? People are working on getting to AGI. And there's all this, like, whenever you see an advancement in AI, they go like, yeah, we're one step closer to AGI. We're getting closer to AGI. Well, any advancement in AI is one step closer to AGI, because that's like the North Star, right? Any improvement you make, you're closer to AGI. So the question now is, how do you know if AGI has been reached, right? Have we already reached AGI? Have we built AI systems which are capable of general intelligence rather than specific intelligence? Well, that is a very controversial topic, and a bunch of people have opinions behind it. There are different attempts at doing AGI, and similarly, there are different attempts at assessing whether something is AGI or not. Okay, there is one particular test by this person called, it's a French name, I'm not going to butcher the name by attempting to pronounce it, right? This is the author of a certain test called ARC AGI pub. Okay, this is a person who has created a series of tests to assess if a certain AI is AGI or not. If an AI passes this test, does it mean that we have reached AGI? No, it is just one person's opinion. Okay, this person feels like this is a good test to assess AGI. And this test has a prize associated with it, right? So this is the ARC prize. The website is literally arcprize.org. Okay, so this is a prize which offers this money for a public competition to beat and open source a solution to the Arc AGI benchmark, right? They've set a benchmark and said, if you have an open source solution, an AI solution, which can beat this benchmark, then they're going to offer this money, okay? And they have like yearly winners. So there is a 2024 winners for these people who have attempted to beat benchmark, right? And I think the highest score gets the prize. Understand? So you have AGI, which is the ability of an AI to do anything you want it to do, like a human. And then you have these benchmarks, which attempt to verify if a certain AI is AGI or not. And this is one such benchmark, which is the Arc AGI. Okay? What's so special about this benchmark? Most AI benchmarks measure skill, but skill is not intelligence. General intelligence is the ability to effectively acquire new skills. This is the key, and you will see this in the subsequent discussion that we're going to have. We have AI benchmarks already. Okay? We have like, it tests against puzzles, it tests against like mathematical, logical challenges, general knowledge challenges, and so on. Basically, what it's doing is it's verifying if this AI can already do such things, right? You give it a riddle and says, can the AI solve the riddle, right? How does the AI know to solve the riddle? Well, it has scoured the internet. It has scanned all these things, and it knows occurrences of previous solutions to the riddle, perhaps. And now if you ask it a similar riddle, it uses that knowledge, it uses the embeddings, it uses the vectors that it has inferred from the previous learning process to solve that particular riddle. You ask it a similar riddle, it can solve it. You ask it something which it hasn't ever heard about, it cannot solve it, right? It's simple. This benchmark claims that that is basically just skill. It's not intelligence. It says the general intelligence is the ability to effectively acquire new skills, not in the process of training, but in the process of interacting with the model. Okay? And we have this unbeaten 2019 benchmark, that is a corpus, is the only formal benchmark of AGI progress. I don't know if it's the only formal benchmark, but it is one of the benchmarks. This benchmark is easy for humans, but hard for AI. Okay, now what does that mean? Here is an example of a test that we're going to give to an AI, and most of the AI cannot solve. Super easy for human beings, most of the AI cannot solve. Okay, here is an example. This is a lot of these Arc AGI tests that are being measured to demonstrate if an AI is AGI or not. A lot of these are input-output combinations, right? You give it an input, and then you give it a sample output that indicates how that input needs to be solved. And then you give it a test input. You expect the AI to learn what the rules are from that initial input-output combination, and then use that same rule to solve the test output, right? Notice here, it's not using existing skills. It's looking at the input and output, and it is trying to learn on the fly, right? Which is what human beings do, and this is what we want the AI to do. So here's an example. We have this input, which is this set of squares, right? You have a shape like this and a shape like this, and here is the output. You have a shape here with a dark blue square, a shape here with a dark blue square. What's happening? We have this kind of like, you assume that the filled version is actual squares, and this portion is missing here, quote unquote missing. This portion is missing. So fill the missing squares of a bigger square with dark blue squares, right? And similarly, here is another example, right? Here, this part is missing, this part is missing, this part is missing. Fill it up with dark blue squares. Now, how would you use this knowledge to solve the problem? Here is a test, okay? Pretty simple. I'm going to say copy from input, so it basically copies this over. Well, wherever there is an empty square, I got to fill it with a dark blue square, which is this, 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 and this, right? Simple for human beings. We see this shape, we see the input and output combination, and we infer the pattern from it. And let's see, submit solution. Well, this is correct, right? This is easy for human beings. Give it to the best AI that's available for us today. It will not solve it because it does not know how to get this and map it to a rule that it infers on the fly, right? This is the goal of this benchmark. It's easy for humans, but hard for AI, okay? So this is the benchmark. This is the Arc prize. Well, now what's the news? What's the announcement? The announcement is that OpenAI O3, there is a new model that OpenAI has announced. They haven't released it, but they've announced it, that has a breakthrough on this benchmark, on this test, right? OpenAI's new O3 system, trained on the ARC AGI-1 public training set, has scored a breakthrough 75.7% on the semi-private evaluation set at our stated public leaderboard 10K compute limit. I'm going to get to that in a bit, right? Basically, they have a new model that scores 75.7% on that benchmark. The other models have been very, very low. So here is the existing models performing on that benchmark. O1 Mini has scored 7.8%. O1 Preview has scored 13.33%. O1 Low, Medium, and High, 25, 31, and 32%. Right? They're pretty low. And we have the O3. There are two versions of this model. There is an O3 Low and an O3 High have scored 76% and 88%. Okay? They are super high, which means that they can solve 76% of the problems, and this one can solve 88% of the problems. Okay? This is the announcement. And this is announced on the ARC webpage. It's not on OpenAI websites. Okay? Why? I have some thoughts. I have a theory behind it. I'll get to that. But right now, they haven't announced it on the OpenAI website. They have announced it on their YouTube channel, which is very weird, and I'll get to that, but not on the website. This is a surprising and important step function increase in AI capabilities, showing novel task adaptation ability. Task adaptation ability is given a task, it adapts, it learns and it adapts, right? That's what they're doing. Never seen before in the GPT family models. For example, for context, the ARC AGI-1 took 4 years to go from 0% with GPT-3 to 5% with GPT-4o, right? GPT-3 was one of the first GPTs that we were experiencing as the general public, right? And from there to the latest, before this announcement, the latest best model, which is 4o, the whole difference has been from 0 to 5%. And now we have gone from 5% all the way to 76% and 88%, which is mind-blowing, right? It seems to be a huge increase. It's a huge increase. But here is the thing. The results are based on a few key things that you need to understand. I'll highlight those things because it's kind of hidden in the announcement. OpenAI's new O3 system. It is, first of all, trained on a public training set, which means that they haven't taken their system or model and basically had it try to solve these problems. Instead, they have first trained it on a public training set, which means that there are certain input and output combinations and the resulting combination that I've used for training. They have trained it. Okay, so it is not entirely, here is a new problem, figure out how to solve it and then solve it, right? They have done an initial training step first. And only after that, it has scored a breakthrough performance result, okay? And these ones, have they been trained? I don't know, they don't say, okay? So maybe they haven't been trained, maybe this has been trained. So it's a little bit of, I don't know, it's not apples to apples comparison. It's not fair to put it like this, because this guy has been trained, this guy has probably not been trained. So if you train this, where will this be? They don't say, okay? All right, next. We tested O3 against 2 data sets, okay? There is a semi-private evaluation, 100 private tasks used to assess overfitting, and then there is a public evaluation, which is 400 public tasks. With AI assessment, with AI benchmarks, they do this. They keep certain tasks as public because people who want to test it, they have a way to test their models. But they also keep certain tasks or certain tests as private because they need to know that the people who are training the models aren't cheating and training on the test set as well. Okay, so there's certain private tests. So here are the results of the tests, right? They have run 100 tests for both. You remember there are 2 versions, right? There is a low compute version and the high compute version of O3. You see here, this is O3 lower compute and then O3 high compute. So they've tested on both, and we have this 75.7% for the semi-private for high. For low, it is, this efficiency, sorry, this is high efficiency and low efficiency, which means compute is opposite, right? This is high compute and this is low compute. So for high efficiency, low compute, it's 75.7. For low efficiency, high compute, it is 87.5. Now, the interesting thing about this table you need to keep in mind is the retail cost and the cost per task. The retail cost for solving 100 tasks, right? The cost it took for having this new system solve 100 tasks was $2,012. Okay, which means that solving each task cost 2012 by 100, right? It's not cheap. And here, yeah, cost per task is $20 approximately. And the time taken per task is 1.3 minutes. This is not cheap. So basically, a prompt, you prompt it and it responds and it costs $20. Okay? That's not the mind-blowing part. Let me tell you this. This one, the high compute, low efficiency, which means it took more resources, the amount of compute was roughly 172x the low compute configuration, 172x, which means if this cost $20, I'm presuming it costs 172 times of $20, right? So roughly you say 200, it's about $400. Okay? For one task. You give it a problem, and for it to solve it, it took about 14 minutes and it costs about $400. So it is very, 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 very expensive. Very expensive. And the idea is that it is able to solve the problem at a very, very high cost. I'm going to point you back to this graph over here. Okay? What you see here in the y-axis is the score, right? How well a model did. What you see in the x-axis is the cost. Okay, this O1 mini costs less than $1. Okay, O1 preview costs a little over $1. Now you notice here the cost, the x-axis, is not linear, right? This is $1. This is $10. This is $100. Yes, ladies and gentlemen, this is logarithmic scale, okay? So at logarithmic scale, this is way out there, and this one is even way out here. So this one's like over 1,000. So this one's 1,000. This one's cost over 1,000. And at that logarithmic scale, I'm guessing this is probably around, I don't know, 10,000 or something like that when it's at this point. Okay, so it is very, very expensive. So there are two things here. First of all, it has been trained on the training set. Okay, it wasn't like a model that was tried to do this on its own. It was trained on the set, and with the training, it needed this much of cost in order to solve this. Okay, well, at least there's two aspects to it. First is two ways of looking at it. First way, you can say, well, this is ridiculous. It's fine. My job is safe as a programmer because I charge less money to solve this problem than O3 does right now. But another way to look at it is, well, we have a new innovative way to solve this problem, and it is eventually going to get cheaper, right? It costs this much money now, but imagine the advancements in computer hardware and better graphics card, cheaper ways to run these models. It is going to get cheaper over time, right? This is true for any hardware that we've had over the years, right? We start out with building software which is very expensive to run, and the software doesn't change, just the hardware becomes better. And now the same software, which was expensive before, is now cheaper to run. Can we say that's the case for O3? Well, if that's the case for O3, well, what is new about this? What does O3 do that makes it such a significant leap? Okay, you see here, despite the significant cost of the task, these numbers aren't just the results of applying brute force compute to the benchmark. They're not doing brute force, is what they're saying. OpenAI's new O3 model represents a significant leap forward in AI's ability to adapt to novel tasks. If you want a smart AI, it has to adapt to a task. It has to figure out how to do it, even though it wasn't explicitly trained to do it. This is what they say it does right now. This is not merely an incremental improvement, but a genuine breakthrough, marking a qualitative shift in AI capabilities compared to the previous limitations of LLMs. O3 is a system capable of adapting to tasks that it has never encountered before, arguably approaching human level performance in the ARC AGI domain. Okay? That's the idea. That's the reason why they feel that this new model is closer to AGI because it has a way to kind of learn on the fly, to figure out on the fly. Okay? All right. How does it do it? Now, you know how the other models, I hope you know how other models do it, right? It's basically a simple way to say this is basically word prediction, right? And the next word prediction is a simple, very reductive way of explaining how these models do it. Well, how does this do it? Well, first of all, let's look at it. So is this AGI? Is it AGI? Have we reached AGI? ARC AGI serves as a critical benchmark for detecting such breakthroughs, but they say here like passing ARC AGI does not equate to achieving AGI. I don't think O3 is AGI yet. O3 still fails on very easy tasks, indicating a fundamental difference with human intelligence, right? Where it's not AGI. How does O3 do things differently from the older models? The way O3 solves this problem is very interesting. I want to explain this to you. So you folks know what chain of thought reasoning is with AI models, right? Basically, when you ask it to do a problem, they solve a riddle or something complicated like that. Well, it makes an attempt and it tries to solve it. But you want to improve the efficiency, in order to improve the effectiveness of this, ask it to think through it, right? Basically say, hey AI, here is my problem. Think and outline the steps to solve this problem and then solve the problem. Okay? You're basically doing the same thing. You give it a challenge, you ask it to solve it, but then you say, outline the steps first. Now, what ends up happening is the AI response is going to first outline the thinking part and then the solution. It's not going to jump right into the solution. Okay? Why does it help? It helps because having the thinking part in the result is going to affect the next tokens that get generated in a more positive way. Okay, let me explain this. You ask a question, right? You ask here is a question, you ask it and say, hey AI, solve it for me. Okay, so the AI starts by trying to solve the problem, right? It's outputting text. So the next text that it outputs depends on what came before it, right? What came before it influences the next text that gets generated. Now, if the AI starts out at the right footing, then it obviously gets to the right answer. But if it makes a mistake or if the starting point is not ideal, then it can easily go off track as well. Because again, what it generates next depends on what it generated before. So you say, instead of saying, okay, just write the text, what if you can set up the AI for success? You say, explain your reasoning first, put that in your response, and then generate the actual response. Now, in that case, what happens is the first set of things that it generates is the thinking. Okay, it says output the thinking first and then solve the problem. So it's basically it's not outputting the solution itself, it's outlining what is the approach for solving the problem, what are the key considerations it needs to take. All those things gets filled in the response first. And then now when it starts writing the response, guess what? Since these depend on the tokens that it generated, now you have a better set of tokens to influence the output in the right direction. Because it's outlined all the thinking, the result that gets generated is more likely to be accurate. It's more likely to be what you want. So this just the fact of you saying, hey AI, solve this problem for me, versus, hey AI, solve this problem, but first outline your thinking process. Just the fact that you say this is going to affect positively the actual result that gets generated. And you can ignore the thinking if you don't like it, or you want to understand how it got to the solution. You can read the thinking process. So basically, you have now, just by changing the prompt, you've effectively made your result better. Okay, so this kind of asking it to reason it through is called chain of thought. It's also referred to as COT, chain of thought reasoning. Okay, like outline the chain of thought that you're going to go through. And you can do this for your AI prompts today. Okay, whenever you're interacting with ChatGPT or Claude or any AI, even a local AI, you say, explain your reasoning first and then come up with an answer. You're going to get better answers, right? A lot of people have done this. They've identified that this is what's going to help. Okay, now what O3 does, this is done in O1. Okay, you have O1, and then there is the better model O1 Pro or whatever, right? It does this, right? It does the thinking and it comes up with a better reasoning. You don't have to say reason it through. It does it on its own and it comes up with a better answer. So they did something to make these models better, right? It's already being done. Now, what does O3 do differently? What O3 does differently is it actually does not one, but multiple chain of thoughts. Okay? It doesn't just do one chain of thought. Here's what it does. You ask it to do a solution. Come up with a problem. You say, hey, AI, here is my prompt, solve a puzzle or whatever. Okay? So here, what it does is, it actually does multiple chain of thoughts. Okay? Here it does one chain of thought, one more chain of thought, one more chain of thought, and so on. Okay? And then it tries to solve this, it tries to solve this, it tries to solve this, and then it evaluates which of these is better. Okay? Is this better, or is this better, or is this better? It's going to pick one which is better, and then it is going to see, is there anything from these ones that it can incorporate into the solution? Maybe the other ones weren't good, but there were some interesting things that it could incorporate into the solution. So it's going to pick that and it's going to take this, and then now it's going to again fork to different things. So basically what it's doing is it's starting out with a tree of possible solutions. Okay, a tree of possible solutions, and then it kind of evaluates which one is better, and then it picks one which it finds it's better equipped to solve this problem, and then it goes from there, and then it does another tree. Okay, this kind of forking and picking the right one has been done with AI already. Okay, there are a bunch of solutions which do this with LLMs, and even before LLMs, there were a bunch of solutions which did this with game solving. Okay, so a chess game with AI. What does it do? It forks, it creates a tree of possible opportunities, possible solutions, and then it backtracks. It tries to evaluate, backtrack, goes into another path, backtracks, finds one, and then you know what I mean? Like the tree option is very, very common for game mechanics, right? For solving for games. Even if you're not doing AI, even if you're doing procedural programming and solving for chess or any of these board games, you do this kind of backtracking approach, right? This is what they've done, but for AI. And this is the reason why, no wonder this thing takes so long, because it's basically trying to solve multiple possible options. It's basically trying to solve different chain of thoughts, evaluating it, going back, and eventually getting to the right solution. Okay? That is the difference with O1 and all the previous GPT models and O3, right? So, okay, first of all, here, for now, we can only speculate the exact specifics of how O3 works. Why are we speculating? Because the person who has written this, the person who's made the O3 announcement, this is super strange. The person who has made this O3 announcement, they're not from OpenAI. They are running this arcprice.org, who has this benchmark for evaluating if an AI is closer to AGI or not, right? They're mentioning this. They say that O3's core mechanism appears to be natural language program search and execution within the token space. At the test time, the model searches over a space of possible chain of thoughts. Okay, you remember how I told you, chain of thought is basically describing the thought and then solving it. They're doing, in this case with O3, it's searching over a space of possible chain of thoughts, doing multiple chain of thoughts, describing the steps required to solve this problem in a fashion perhaps not too similar to Monte Carlo tree search. Monte Carlo Alpha Zero is basically the AI model which is used to solve games like chess, right? So they're doing this multiple chain of thoughts and then seeing what is better. And then in the case of O3, the search is presumably guided by some kind of an evaluator model. They do multiple chain of thoughts and then they evaluate. an evaluation is needed as well, right? Not only do you do these multiple chain of thoughts, you also have to see which one is good. Is this good? Is this good? Is this? You need some kind of a way to evaluate. Is this going in the right direction or not? As long as you have that, you can say, do 10 attempts at this thing and then see which attempt is closer. And then you go from there. And now you have got to this point, do 10 attempts and see which one is going to get closer. So now you have multiple different approaches and you can eventually narrow down to one solution, which is what makes it more effective, also what makes it more expensive, right? So while a single generation LLM struggles with novelty, O3 overcomes this by generating and executing its own programs, where the program itself, the chain of thought, becomes the artifact for knowledge recombination. Okay, so it basically takes that chain of thought, different chain of thoughts, and then it uses that knowledge in order to do further chain of thought and in order to further solve the problem. Effectively, O3 represents a form of deep learning guided program search, right? So this is the term that's used to indicate this new approach for AI. This could very well be the new way of all these AI models working, okay? It's called deep learning guided program search, right? It's deep learning guided, right? It's using this evaluation model and it is doing a program search. A program is basically an approach, right? A chain of thought is basically what tells it how to go about it, right? It's not a program as in you writing the code. It is a program as in the AI is saying how it is going to solve the problem, right? It's a program using natural language. The AI is going to say, first I'm going to do this, I'm going to do this, I'm going to do this, right? That's one chain of thought. Another approach. I'm going to do this, I'm going to do this other thing, and I'm going to do this other thing. Another chain of thought, all right? Now we're going to have a learning guided program search. Now, among those different programs, different approaches, there's a learning guided way of picking the right program and then using it to further solve the problem, all right? The model does test time search over a space of programs. In this case, notice here, natural language programs, the space of chain of thought that describes the steps to solve this task at hand, guided by a deep learning prior base LLM. The reason why solving a single Arc AGI task can end up taking tens of millions of tokens and cost thousands of dollars is because the search process has to explore an enormous number of paths through program space, including backtracking. Here is a simple way to explain this. Okay, we aren't having one smart model solve the problem. Okay, we are having a bunch of dumb models solve the problem, and then we are picking which dumb model is less dumb, which is closer to the solution, and we're gonna fork a bunch of solutions from there. Does that make sense? That's really what it is. So you have a way to basically have these LLMs do whatever it wants, but selectively refine and pick, right? Do survival of the fittest and selectively pick the right approach and then get to the solution, all right? So, and if this works out well, if this can solve problems better, this could very well be the model that is used for future improvements to AI, right? Very expensive, but it works. It solves the problem.